A bucket full of sand has a mass of 25 kilograms, including the bucket and the sand. The bucket is to be lifted to the top of a building 15 meters tall by a rope of negligible weight. However, the bucket has a hole in it and leaks 0.2 kilograms of sand each meter it is lifted. We want to find the work done lifting the bucket to the top of the building. So looking at our notes below, if an object moves in a straight line by a continuous force, big F of x, then the work done by the force from x equals a to x equals b is given by this def integral. So the first step is to find big F of x, the force function. But notice in this problem we're given information about the mass, not the force. So to find big F of x, we'll have to use the formula force equals mass times acceleration, where because the mass is in kilograms, the acceleration due to gravity is 9.8 meters per second squared. So using force equals mass times acceleration, let's work on determining big F of x. Big F of x is equal to, and we'll have to write an expression for the mass because the mass starts at 25 kilograms, then leaks 0.2 kilograms each meter. So the expression for the mass would be 25 minus 0.2x, where x would be the number of meters the bucket and the sand is lifted. And then times the acceleration due to gravity, which is 9.8 meters per second squared. Let's go ahead and distribute. So big F of x is equal to 9.8 times 25 is equal to 245 minus 9.8 times 0.2x is equal to 1.96x. And because the bucket full of sand is lifted to the top of a 15-meter tall building, we know x will be greater than or equal to 0 and less or equal to 15. So we'll use this interval as the interval of integration, which means the work done lifting the bucket to the top of the building is equal to the integral from 0 to 15 of big F of x, which we now know is 245 minus 1.96x integrated with respect to x. Let's go ahead and evaluate this on the next slide. Integrating with respect to x, we would have 245x minus 1.96 times x squared divided by 2. Well, 1.96 divided by 2 is equal to 0.98. So we have minus 0.98x squared. And again, the limits of integration are from 0 to 15. Now we need to find big F of b minus big F of a. So when x is 15, we have 245 times 15 minus 0.98 times 15 squared. Of course, when x is 0, both terms are 0. So simplifying, 245 times 15 is equal to 3,675 minus 0.98 times 15 squared is equal to 220.5. Subtracting, we get 3,454.5, and the units would be joules. So going back to our first slide just for a moment. The amount of work done lifting the bucket to the top of the building, again, is 3,454.5 joules. I hope you found this helpful.